Example 4. Convert each angle in degrees to radians. Express your answer both as a multiple of pi and in decimal form rounded to 2 decimal places. All right, so we're going to be doing a lot of conversion here. This particular example is converting from degrees to radians. Okay, so we just talked about the conversion factors, going both from degrees to radians and also from radians to degrees. So all you have to do if you forget the conversion factor is refer back to the previous page and look at the bottom two bullet points, and that's where we develop the conversion factors. Okay, all right, so let's go ahead and get started. So in part A, we are going to convert 60 degrees into radians. Okay, so you're going to take 60 degrees, okay, and you can flip back and, like I said, multiply by the conversion factor, but that would require you memorizing the conversion factor. So what you should do is just reason through this. Okay, we're trying to convert from degrees to radians. Okay, so you're going to multiply by your conversion factor, which is going to be a fraction, and you're trying to get rid of degrees. So since you have degrees in the numerator, you're going to put degrees in the denominator there, okay? And you want to be left with radians, so that's what's going to go in the top, okay? So your conversion factor, what you're essentially multiplying by, you want to be multiplying by 1, okay? You cannot change the original angle. You cannot change 60 degrees to a different quantity. So since you're multiplying by something, it has to be 1, otherwise it will change the 60 degrees that you're starting with, okay? So our conversion factor, okay, has to be a fraction. It has to have the same thing in the top as in the bottom, okay? Well, what did we learn just now, okay? A few minutes ago, we learned that 180 degrees is the same thing as pi radians, okay? So in our conversion factor, we know the fact that 180 degrees is the same thing as pi radians, okay? And remember, that is the conversion factor that we have listed right here, okay? All right, so all we have to do is do this multiplication, okay? Notice you have degrees in the top and in the bottom, so degrees will cancel out and leave you with radians, okay? So we can go ahead and multiply here. You can put the 60 over 1, and then you're multiplying fractions, so you can just multiply across the top. So this is going to be 60 pi over, multiply across the bottom. 1 times 180 is 180, okay? And so there you go. This reduces, okay? Both 60 and 180 are divisible by 60. So 60 divided by 60 is 1. So that's going to leave you with pi in the top. And then 180 divided by 60 is 3. Okay, so your answer here is pi over 3. Okay, 60 degrees is equivalent to pi over 3 radians. Okay, now be careful with the directions. The directions said to express your answer both as a multiple of pi, and that means exact answer here. Okay, meaning no decimals. So exact answer, no decimals. And that is actually what we just did. Okay, we have a multiple of pi here because pi is in our answer and it's not a decimal, okay? But you're also asked to express the answer as a decimal rounded to 2 decimal places. The reason we're practicing in both ways is because my math lab can ask you in either way, okay? They can ask you to convert to radians and give the answer as an exact answer, meaning a multiple of pi, or give it as a decimal, so you need practice with both, okay? All right, so we are going to go to our calculator and punch in pi over 3 and get the decimal approximation. All right, so let's go to the calculator. We're going to type in pi divided by 3, okay? And there you go. Okay, we're going to round in the directions. It says to 2 decimal places, so that means 2 decimal places, 2 places after the decimal point. So we've got 1.047. Okay, so we've got 0.4 is the 2 places. A 7 comes after, so we're going to have to bump it up to 1.05. Okay, so this is going to be equivalently, we're going to put the approximately symbol here because now we're estimating. Okay, up here when we have pi over 3, that's an exact answer, so we can put that actually equals, but now we're going to an approximation that's going to be 1.05, I believe, okay, radians. Okay, again, you can put radians, RAD, if you want to. You can also just leave it unitless. Okay, so you don't even need the rad if you don't want to put it there. Okay, so there you go. You've got both the exact answer and the decimal approximation. Okay, so that's all you have to do for these. Okay, if you're converting from degrees to radians, you're just going to multiply by pi over 180. Okay, so let's look at example B. So now we're changing 150 degrees over. Okay, so we're going to take 150 degrees and we're going to multiply by our conversion factor. When we're multiplying by the conversion factor, since you're trying to get rid of degrees, degrees has to go in the denominator so that degrees in the top, degrees in the bottom will cancel, and you need to put radians in the numerator. Okay, your conversion factor is the fact that 180 degrees is the same thing as pi radians. Okay, because this conversion factor, pi radians, 180 degrees, they are equivalent. Anything divided by itself is 1, so you're really multiplying the 150 degrees by 1. You're not changing 150 degrees. Okay, all right, so you've multiplied. We can go ahead and put this over 1 and then multiply across the top and across the bottom. Degrees will end up canceling, leaving you with radians. Okay, so this is going to be, if you multiply across the top, 150 pi over 180. Okay, and then you can go ahead and reduce the fraction, the numbers 150 divided by 180. Okay, both of these numbers are divisible by 30. Okay, so 150 divided by 30 is 5, so you're gonna have 5 pi, and then in the bottom 180 divided by 30 is 6. Okay, so your answer here is going to be 5 pi over 6. 150 degrees is equivalent to 5 pi over 6 radians. Okay, again, we need to get a decimal approximation for this. This is the exact answer. This is the multiple of pi answer they're looking for. So we're going to go punch it into the calculator to get an approximation. Okay, so we're just going to do 5 pi divided by 6. Okay, round this to 2 decimal places. So we've got 2.61. After the 6.1 comes a 7, so we need to bump it up to 2.62. Okay, so this is approximately 2.62 radians. Okay, so there's your approximation. Okay, all right, so let's keep trying. Okay, in part C, we have a negative angle, so this is negative 45 degrees. It's going to work the same way. You're going to take negative 45 degrees, you're going to multiply it by pi radians over 180 degrees. Okay, that way you have degrees in the top, degrees in the bottom, they cancel, leaving you with radians. Okay, all right, so now we can just multiply across the top and across the bottom. This is going to be negative 45 pi over 180. Okay, so you can go ahead and reduce this fraction. Okay, the angle has to stay negative. If it's negative in degrees, it's going to stay negative if you're converting it to radians. It's still going to be a negative angle. Okay, so keep your negative sign. We can go ahead and reduce this. Maybe you don't know how to do this on the calculator. You can do 45 divided by 180. Okay, it'll give you the decimal. Okay, and then if you hit math and you hit option 1 to do fraction, you can convert anything to a fraction. Okay, so 0.25, we know that that's 1/4. Okay, all right, so this is going to simplify to be negative 1 times pi over 4. Okay, you can just write this as negative pi over 4. Okay, so there's the exact answer. Negative 45 degrees is equivalent to negative pi over 4 radians. Okay, we can get an approximation, so we need to punch this into the calculator. Okay, so we're going to do negative pi over 4. Okay, so the decimal approximation to 2 places, you've got negative 0.785. So following the 7.8 is a 5, so we're going to bump up to negative 0.79. Okay, so this is approximately negative 0.79 radians. Okay, all right, continuing on, 90 degrees, good old right angle, 90 degrees. Okay, how much does that measure in radians? Okay, all right, so we're going to take 90 degrees. Okay, we're going to multiply by pi radians over 180 degrees. Okay, so we are going to have degrees in the top, degrees in the bottom. They're going to cancel out, leaving you with radians. Okay, so multiply your fractions. The 90 is really over 1. Okay, so this is going to be 90 times pi over 180. Okay, this will reduce. Okay, so 90 goes into 90 one time, 90 goes into 180 twice. Okay, so this reduces to be pi over 2. Okay, this is very important. You will see this again and again. 90 degrees is the same thing as pi over 2 radians. Okay, so there's your exact answer. Okay, if we go to the calculator and punch in pi over 2 to get a decimal approximation, okay, this is 1.57 radians. Okay, so I'll put approximately 1.57. Okay, all right, and again, we're not putting units because radians are essentially unitless. Okay, last one, part E. Okay, now we've got some kind of random degree measure. Okay, 107, okay, degrees. We're going to convert the same way. Okay, so we're going to multiply by pi radians over 180 degrees. Okay, and degrees in the top cancel with degrees in the bottom. Okay, you can go ahead and multiply your fractions, put the 107 over 1. Okay, so this is going to be 107 times pi over 180. Okay, so this is going to be your exact answer. I don't believe that the 107 divided by 180 reduces. We can check on the calculator here. Okay, so if we try to convert this to a fraction, so if you do math, option 1 for fraction, okay, you get 107 divided by 180 back. Okay, so this fraction does not reduce. Okay, so here is your exact answer. Okay, do not, in any of these problems, don't forget the pi. Okay, 107 divided by 180 is not the same thing as 107 times pi divided by 180. Make sure you carry the pi if you have to. Okay, all right, we need a decimal approximation of this. Okay, so we're going to have to go to our calculator and we're going to punch in 107 times pi, okay, divided by 180. Okay, and there's your decimal approximation. So this one's going to be 1.86. There's a 7 after the 86. So we're going to have to bump it up to be 1.86, or sorry, 1.87 radians. Okay, so 1.87 radians. There's your decimal approximation. Okay, so this was some good practice converting from degree measure to radian measure.